Hey everyone, welcome back. We're going to be diving into something a little bit different today, biotechnology and how it's becoming a major player, on the global power stage.
Yeah, it's not just about medicine anymore.
Right, like it's way beyond that
It's
now.
absolutely.
So we're going to be looking at, we're kind of unpacking all of this based on the work of Alexander Titus, who sits on the U.S. National Security Commission on Emerging Biotechnology.
The NSCEB.
Yes, exactly. And he's made a pretty compelling case for how this is all unfolding.
Hmm.
So, ready to explore how biotech is really impacting, global industry and power dynamics.
Absolutely. Let's jump in.
All right, first up, let's talk about food. We've all heard of farm to table, but get ready for tank to table. Precision fermentation is kind of changing the game here.
Yeah, it's really interesting how we're essentially brewing food ingredients now.
Hmm.
We're using microbes in large tanks to create things like milk proteins and the enzymes needed to make cheese.
Wow.
And this could really, revolutionize food production, make it more efficient and even localized.
That's a huge shift. And remember that $330,000 lab-grown burger that made headlines a few years back? Well, it looks like lab-grown meat is actually making its way to our plates.
It is it's amazing how quickly this technology has advanced.
Yeah.
Singapore approved the sale of cultivated meat back in 2020, and just this year, the U.S. gave the green light for cultivated chicken to be sold in restaurants.
It makes you wonder, what does this mean for the future of the meat industry globally? Will countries that kind of master this technology have a new kind of food power?
It's definitely something to consider. And it's not just about meat, right? Biotech is using gene editing tools like CRISPR to engineer crops that can handle whatever climate change throws at them.
Like that scuba rice developed in India?
It could
Crops that
almost
can grow underwater. That's pretty wild.
Absolutely. Future-proofing food security is a major concern for governments worldwide.
For sure.
Imagine the implications if a country could not only feed its own population, but also control the supply of these climate-resistant crops on a global scale.
It's almost like a new kind of agricultural dominance, but on a genetic level.
Exactly. And speaking of agriculture, traditional farming relies heavily on fertilizers that have a huge environmental impact. But biotech is stepping up to address that challenge as well.
Right. By using microbes, companies like Pivot Bio are giving plants their own built-in nitrogen factories.
It's amazing.
Less pollution and lower costs for farmers.
It's a win-win. I was reading about a pilot program where farmers who use this microbial solution could reduce their synthetic fertilizer use significantly without affecting their yields.
Wow.
It's clear that biotech is starting to provide solutions that are good for the planet and good for business.
Absolutely. And what about energy? We're seeing a shift beyond corn ethanol to things like algae that can capture CO2 and turn it into fuel.
It's a game changer. Imagine sustainable aviation fuel or renewable diesel produced entirely from algae.
Yeah.
We're also seeing microbes being used to turn agricultural waste into ethanol, opening up even more possibilities for biofuel production.
That's incredible. And what about this company, LanzaTech? They're capturing industrial emissions and using microbes to turn them into fuel and chemicals.
They're actually the first ever carbon recycling company to be listed on the stock market.
Yeah.
They already have operational plants in China demonstrating the commercial viability of this technology.
So it's like turning pollution into profit.
Yeah.
And I think it really highlights how biotech is blurring the lines between sustainability and economic growth. It's not just about doing what's good for the planet, it's about creating entirely new industries and reshaping the global energy landscape.
Absolutely.
It's really fascinating stuff.
And this innovation isn't limited to, just food and energy. Biotech is revolutionizing the materials we use every day, everything from fabrics to plastics to even building materials.
Wait, are you telling me we can grow buildings now?
Well, we're not quite growing skyscrapers just yet, but the concept of bio-based construction is gaining traction.
Okay.
We were talking about how microbes are making food ingredients. Well, they can also create materials. There are companies out there making fabrics from spider silk proteins produced by microbes.
So no more silkworms. You're telling me we could have spider silk clothing made from these proteins?
It's not quite that simple, but the potential is there. And it's not just silk. Some companies are even using mycelium, the root-like structure of mushrooms, to create mushroom leather.
Wow, that's pretty mind-blowing. But what about something a little less glamorous but equally important, plastic? We all know it's a huge environmental problem. Can biotech offer any real solutions in this area?
It can, and it's doing so in a couple of really interesting ways. First, there's the development of bioplastics, which are made from renewable biological sources and designed to be biodegradable.
So no more plastic bottles floating in the ocean for centuries.
That's the goal. One promising type of bioplastic is called PHA, which stands for polyhydroxyalkanoids.
Okay.
These are bio-based polymers that can break down naturally in the environment.
I see.
Companies like Danimer Scientific are already using PHA to create biodegradable straws and other products.
That's great news. But what about all the plastic that already exists? Is there a way to deal with that massive amount of waste?
There is. Scientists are engineering enzymes that can actually break down existing plastic.
So you're saying we can actually recycle plastic for real this time, not just downcycle it into lower quality materials?
Exactly. A company called Carbios has developed an enzyme that can break down PET bottles in just a few hours. This type of enzymatic recycling could be revolutionary. Imagine a world where we can truly recycle plastic over and over again. That would have a huge impact on our reliance on fossil fuels and go a long way in addressing the plastic waste problem.
Right. Now let's get back to those buildings we were talking about. Is it really possible to grow bricks and other building materials?
It might sound like science fiction, but researchers are exploring using bacteria to do just that. Certain types of bacteria naturally produce calcium carbonate, and this can be used to essentially grow bricks.
So we could actually have buildings made with bacteria.
It's still early days, but the potential is there. And it goes beyond just bricks. Researchers are also working on self-healing concrete that uses bacteria to repair cracks.
So buildings that can repair themselves. It sounds like something out of a comic book.
It does, doesn't it? This idea of biofabrication has huge implications. Imagine being able to grow furniture from fungal mycelium or create complex structures with the precision and efficiency of nature. It could change the way we think about manufacturing and construction entirely.
Okay, so we've seen how biotech is revolutionizing everything from the food we eat to the clothes we wear to the very buildings we live in. But how does all of this stack up against industries like the semiconductor industry? We know how much those technologies have shaped the world.
It's a great question. And it's important to remember that building with biology comes with its own unique set of challenges.
So you're saying biotech fabs, the facilities where all this biomanufacturing takes place, are different from those massive semiconductor fabs we've all heard about?
Definitely. Let's start with cost. Building a cutting-edge semiconductor fab can cost upwards of $10 billion. Biotech plants are generally cheaper to build, but they still require a substantial investment, often in the hundreds of millions of dollars.
That's still a pretty hefty price tag. What else makes biomanufacturing so different?
Scaling up living organisms is a different ballgame compared to etching transistors onto silicon wafers.
Okay.
With a chip fab, you have incredible precision and control over the manufacturing environment.
Right.
But with living organisms, there's always an element of unpredictability.
Because cells can mutate and behave in unexpected ways.
Exactly. You have to deal with variables that can multiply and mutate. Contamination is a huge risk. Imagine a tiny dust particle wiping out an entire batch of chips. The same thing can happen in a biomanufacturing facility, except it might be a rogue microbe that contaminates the entire production run.
That sounds like a costly mistake.
It can be. And it's not just contamination. Living cells are sensitive. They need the right temperature, pH, and nutrients to thrive. Controlling all of these factors at scale is a huge challenge.
So it's not as simple as just throwing some cells in a tank and letting them do their thing.
Not at all. It's a delicate and complex process. But despite these challenges, governments around the world are starting to recognize the strategic importance of biotechnology and the potential it holds.
You're talking about this bioeconomy race we've been hearing about, where nations are competing to become leaders in this emerging field.
That's right. The US, China, and other countries are investing heavily in biotech, much like they did with semiconductors in the 20th century.
It sounds like the stakes are pretty high.
They are. The country that controls the bioeconomy could have a significant advantage in the 21st century. It's not just about making cool new stuff. It's about national security and global power.
Okay, so we've got this intense competition playing out on the global stage. But what about the role of artificial intelligence in all of this? Where does AI fit into the biorevolution?
AI is becoming a crucial bridge between the worlds of biology and technology. Think about AlphaFold, the AI that can predict protein structures.
I've heard of that. So AI is helping us understand and engineer the building blocks of life.
Exactly. And that's just the beginning. AI is being used to design new biomolecules, control bioreactors, and accelerate research and development in both the semiconductor and biotechnology industries.
So AI is speeding up the pace of innovation in biotech, just like Moore's law did for chips.
Precisely. AI is becoming as important to biotech as lithography was to semiconductors. It's helping to drive the biorevolution forward at an unprecedented pace.
It's amazing to think about the possibilities when you combine the power of biology with the intelligence of AI. What could the future hold with these two forces working together?
It's really exciting to consider. We're already seeing incredible advancements in areas like personalized medicine, synthetic biology, and even biocomputing.
Mhm.
But the true potential of this convergence is still unfolding.
It sounds like we're just scratching the surface of what's possible.
I think that's a great way to put it. The bioindustrial revolution is still in its early stages,
Yeah.
but it's moving fast. And it's clear that AI will play a critical role in shaping its future.
So we've got biotech kind of revolutionizing entire industries and governments, pouring resources into this bioeconomy race, and then AI adding fuel to the fire. It's a lot to take in.
It really is. And you know what's interesting to me is this dynamic between collaboration and competition. While countries are definitely vying for leadership in this space,
Yeah.
there's also a growing recognition that we need to work together to tackle these, huge global challenges.
Right, like climate change and things like that. It's
Exactly.
not just about national pride, it's about, the future of the planet.
That's right. And I think that's what makes this whole race so compelling. The stakes are high, but the potential rewards are even greater.
So let's play this out for a second. Let's say everything goes right and this bioindustrial revolution, really takes off. What does that future look like?
Well, imagine a world where, everyday products proudly display labels like, you know, bio-designed in the USA or made with biotech, similar to how we see, Intel Inside on computers today.
So bio-based products become the norm.
That's the vision. And it goes beyond just consumer goods.
Mm.
Imagine biorefineries dotting the landscape, efficiently turning waste into fuel and valuable materials.
So kind of a shift toward localized production, reducing our reliance on these, complex global supply chains.
Precisely. And as these technologies mature and become, more cost-effective, we could see a real transition toward a circular carbon economy.
A future where we're reusing and recycling carbon instead of constantly, extracting it from the earth.
Exactly.
Yeah.
Sustainability would be built into our, industrial processes from the ground up.
It sounds pretty amazing, but how does this bioindustrial revolution change the global balance of power? Could it create new leaders on the world stage?
It definitely has that potential. Countries with robust bioeconomies could gain a significant advantage, not just economically, but also in terms of global influence.
So the bioeconomy could reshape the geopolitical landscape.
Absolutely. And it's not just about the U.S. and China. Other countries, especially those with abundant biomass resources, could also emerge as major players.
You're talking about countries like Brazil with its sugarcane or Indonesia with its palm oil.
Precisely. These countries could leverage their resources to become leading producers of biofuels and bio-based materials. We could see a more multipolar world, with multiple centers of power emerging in this bioeconomy.
It's a fascinating thought, but with all this talk about competition and power, it's easy to forget about the human element. How does this revolution impact people's lives on a day-to-day basis?
You're right. It's crucial to remember that this revolution isn't just about abstract concepts like, national economies or global power dynamics. It's about improving people's lives.
So how does it do that?
Well, for starters, we've talked about how biotech can address food security and help mitigate climate change. These are fundamental challenges that affect everyone on the planet.
Right, and what about jobs? Does this create new opportunities?
Absolutely. As these new industries emerge, they'll need skilled workers to design, build, and operate these bio-based factories.
So we're not just talking about scientists and engineers.
Not at all. We're talking about technicians, operators, and a whole support ecosystem around these new industries. The bioindustrial revolution has the potential to create a lot of prosperity, and not just in economic terms. It's about building a more sustainable and resilient world for future generations.
Well, this deep dive into biotech has been incredibly eye-opening. It's amazing to think about how these tiny organisms, these microbes and DNA, could have such a profound impact on our world.
It is, isn't it? It really underscores the immense power of biology and its potential to reshape our future.
I'm definitely going to be paying much closer attention to this field from now on, and I encourage all of you listening to do the same. The future of biotechnology is the future of our world.
That's a great point. Right, to end on this, revolution is still in its early stages, but it's moving fast. It's up to all of us to stay informed, engage in the conversation, and help shape this exciting future.
So there you have it, our deep dive into the world of biotech, a story of innovation, competition, and the potential to create a better future for us all.
A future that's well worth working towards.
Until next time, keep exploring and stay curious.